All right, calculus friends. So here we are again, doing some nice integration. And we're going to do some definite integrals. And this may be a little bit repetitive from the video you already saw from the organic chemistry tutor, but there are a couple of things in here that I do want to show you that I don't think that he did. Okay, so let's take a look at this integral right here. We got integral from 0 to 1 of 2t minus 1 squared. And since we've been talking about u substitution, it seems like, well, you know, I could call 2t minus 1 u, and then du dt, blah, 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 and I get a 2 here and a 1/2 out there, and blah, blah, blah. That's all fine and good. We can use u substitution if we want to. But we can also recognize that we could just square this out. And that's what I'm going to recommend here. No sense pulling out the big guns when, you know, when easier or smaller tools will work just fine. All right, so we're going to do 0 to 1. We're just going to square this out. So we get 4t squared minus 4t plus 1 dt. And then we integrate all of those pieces. And so we get 4t cubed over 3 minus 4t squared over 2 plus t. And of course we don't need plus c. And we're just going to evaluate this on 0 and 1. So we're going to plug in, actually we could reduce this down here, right? So we just reduce this down. We get a 2, so it's just 2t squared. So we're going to plug in 1 here, so we're going to get, plugging in 1 here, here, and here. We're going to get 4/3, right? I kept my life easy by using that nice easy number. Minus 1 squared, so 1 cubed, of course, is 1, times 4/3 is 4/3. 1 squared is 1, times 2, of course, is 2. Make sure I don't mess that up. And then plus 1. So that's just plugging in 1, and then I'm going to plug in 0, 0, 0, 0, so minus 0. So let's see what happens right here. So 4/3 is 1 1/3, minus 2 is negative 2/3, plus 1 is positive 1/3, minus 0 is positive 1/3. So there's our answer, 1/3, and that's it. Okay. So again, just because I've shown you use substitution doesn't mean you have to use substitution in every problem. All right, let's take a look at the next one here. This one's already written in terms of u, so if we did use substitution, it would be, you know, kind of almost redundant, but we would manage it. So again, seeing a binomial or any sort of polynomial in the numerator with a monomial in the denominator just means we're going to divide the monomial into each of the pieces of the numerator. Going 1 to 8, we're doing a cube root, so that's going to make our life pretty easy here because we know cube root of 8 is just 2. Okay, so we're going to rewrite this as u to the 1/3. So we have the integral of, I should say that this is equal, 1 to 8, or 8 to 1, of u plus 3, u to the 1/3 du. And that's going to be equal to integral of 8 to 1, or 1 to 8. And then we're going to divide. U to the first divided by u to the 1/3 is u to the 2/3. And this is going to be plus 3u to the negative 1/3. Just bringing this one up. And then we have du. And we integrate here. So u to the 2/3, we add 1, which is really 3/3. So now we're going to have 5/3. So we're going to have u to the 5/3 divided by 5/3, which is really times 3/5. And we'll do the same trick here. We're going to add 3/3 to negative 1/3 and get 2/3. So we get plus 3u to the 2/3 over 2/3, aka times 3/2. Crap, I didn't write this very well. Times 3/2, I'll just put that right here. And yeah, and then we'll evaluate that on 1 to 8. And let's do that over here. So let's put in 8 right here. The cube root of 8 is 2, to the 5th power is 32. So we got 3 times 32 is 96, so we got 96 over 5. and we'll plug in 8 right here. Cube root of 8 is still 2, squared is 4, times 3 is 12, divided by 2 is 6, times 3 is 18. So we have plus 18. And then we'll subtract. We're just going to plug in 1 here and here. So we got 3/5 plus 9/2. 3/5 plus 9/2. And to save everyone some time here, I'm just going to say, I'm pretty sure we can all evaluate this. Find common denominator here, find common denominator here, get a fraction, subtract, blah, all set. So, again, I'm convinced that we can do the arithmetic here. The key idea here, of course, was making sure we divide into both pieces here. Okay. 2 down, a few more to go. So this has some similarities because it has fractional exponents. And we'll again do the same thing as we did before. So just integrating, and we don't need to do anything tricky here, right? This is just a variable to a power, variable to a power. So we just, again, integrate as is. So we're just going to add 1 here, which is 4/4. So this is going to be t to the 5/4 divided by 5/4, which is really the same as multiplying by 4/5. And then we're going to subtract, and we're going to add here 4/4, so that's 7/4. So we have t to the 7/4 divided by 7/4, aka multiplying by 4/7. We're going to evaluate that on 0 to 16. And again, we get the same stuff as before. The 4th root of 16 is 2 to the 5th power is 32. Times 4 is 128 over 5. 128 over 5. Plugging in 16 here. 4th root of 16 is 2 to the 7th is, crap, I didn't think about that. 128, 256, 512. Damn it, 512 times 4 is 2048 over 7. Minus 2048 over 7. I may have needed to vet this problem before I actually gave it to you. Plugging in zeros, and so we get minus 0. Again, find the common denominator, do the work, blah, 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 and you'll be fine with an answer. Okay. This one here is completely different. So we should remember that the absolute value function is really 2 functions. It's really a piecewise function. And we should think of it in its 2 pieces. So 3x minus 6, the absolute value of 3x minus 6, will have the pointy part at wherever this thing here becomes 0. And this thing here is clearly going to become 0 at 2, right? 3 times 2 is 6, minus 6 is 0. And so, I'm just going to draw a little sketch here. We don't really need to. We're going from 0 to 4. So I just need to go out 1, 2, 3, 4. And when we plug in 0, we're going to get, well, 0 minus 6 is negative 6, but the absolute value is 6. So we'll be up here at 6, and we go to 2. So what this graph looks like is this, and then this. And what we're really looking for here is, as we talked about today, area under the curve, or between the curve and the x-axis. We're looking for this, and this. So what this integral can be represented this way graphically. So what we're really going to do here is we're really going to just do 1/2 of this, right? I'm just going to say, hey, let's integrate from 0 to 2 and then double it because it's symmetric. The question is, from 0 to 2, what exactly is it that we are integrating? Well, we're integrating this function right here. And what is this function? Well, we remember that absolute value is really a positive function and a negative function. So when we are past 2, right, to the right of 2, it's the positive function, 3x minus 6, right? Slope of 3. And if we extend this down here, we'll have a y-intercept of negative 6 down here. So that's the positive part. Over here, we have the negative part, and that's pretty easy to figure out what that is. We're just going to flip the signs of both of these guys here. So in order to get this function, I'm just going to change each of the signs right there. So I'm going to rewrite this integral here as, this is equivalent to 2 times, right, I'm just going to double this, 2 times the integral from 0 to 2, right, we're going to go from 0 to 2, of the negative of this function, right, because we're just negating that function because it's the negative half of the absolute value. So we have negative 3x plus 6 dx. And we don't need the absolute value anymore because we broke it into one of its 2 pieces. So, and we did the 2 again just to make sure we have the, or taking care of the symmetry. So we're just going to integrate and do this piece, double it, so we can get the full amount. All right, so carry along our constant multiplier, and then we integrate this. So we have, so I'll just put some parentheses here. So we got negative 3x squared over 2 plus 6x. We're going to evaluate that on 0 to 2. And again, we don't need to really worry about the 0 part because that's just going to become 0 inside there. So we'll just plug in the 2. So equals 2 times, and then plug it in 2. So we got 2 squared is 4, divided by 2 is 2, times negative 3 is negative 12. And something has gone horribly wrong here. Let me just make sure I did this right here. 2 squared is, oh, negative 6. Okay. Whew. Sorry, that's a 6, not a 12. Right? 2 squared is 4. 4 divided by 2 is 2, not 4. And negative 3 times 2 is negative 6. Okay, there we go. Good. And then plug it in 2 here. 6 times 2 is 12, so it's plus 12. Put big parentheses here. Minus 0. Right? Plug it in 0 here. So negative 6 plus 12 is 6. But we're really doubling it. Well, actually 6 minus 0 is 6. And then we're doubling it. So the final answer for this integral from 0 to 4, the absolute value of 3x minus 6 is 12. And again, just using symmetry here and breaking the absolute value into its 2 component parts, the positive part and the negative part. And we just used the negative part and doubled it. Okay, I think that was the big lesson for that. Okay. It wouldn't be a calculus day without some trig. So here it is. We have some trig and even a trig identity too. So here we have 1 minus sine squared. Oh, right. Yes, we're good here. So we have 1 minus sine squared x. And 1 minus sine squared x, of course, is cosine squared x. Oh, this is actually easier than I thought it was. Damn it. 0 to pi over 4. So the top is cosine squared x. Theta, I mean. The bottom is cosine squared theta. Not happy with my selection of problem here. I stole it right out of the book, by the way. And so cosine squared theta divided by cosine squared theta is just 1. So we're integrating from 0 to pi over 4. I am desperately sorry that you are being deprived of your trig function here. Maybe I'll do another one. I'll just make it up. So incidentally, cosine squared theta, where cosine squared theta is just 1. When we integrate 1, we just, with respect to theta, we just get theta. So this is really theta from 0 to pi over 4. So we'll plug in pi over 4, and we get pi over 4. Plug in 0, we get 0. Pi over 4 minus 0 is pi over 4. So this is just pi over 4, and that was a ridiculous problem. It was just dumb. All right, let me just make one up on the fly here. All right, so let's do the integral. Let's stick with 0 to pi over 4. Let's do that anyway. We can manage that, I think. And let's do... hold on, I know the answer to this. We can pull this off. So let's do cosine over cosine squared. That's what we're going to want. We're going to want over cosine squared. Cosine squared theta, d theta. And I'm going to want a 1 plus cosine squared. Yeah, that's what I want. Cosine squared theta. Okay, good. So we're going to do this problem right here. And again, we have a polynomial in the numerator. We have a monomial in the denominator. So we divide in and we divide in. And so that's going to get us 0 to pi over 4. And 1 over cosine squared theta, we know to be secant squared theta, using again an identity. And then cosine squared theta over cosine squared theta, of course, is just 1. So we got plus 1 d theta. And we can integrate each of these two pieces because we know that secant squared theta is the derivative of tan theta. So we're going to have tangent theta here, tan theta, plus the integral of 1 is just theta. And we do that on pi over 4 to 0. Oh, look how awesome this is going to work out. Then we're going to plug in pi over 4. So the tangent of pi over 4, we all know, is 1 because you've been reviewing that. And plugging in pi over 4 here is plus pi over 4. And we're going to subtract away. Plugging in 0, tangent of 0 is 0, plus theta, which is 0, plugging that in, so minus 0. So our final answer is 1 plus pi over 4. Okay, and that's pretty good. Making up a definite integral, a trig definite integral on the fly. Yeah, feeling pretty good about that. Okay, so so here is an opportunity for us to do some u substitution. And yeah. So obviously here u is going to be the inner function, so that's going to be equal to 1 minus x squared. And then we get du dx equals negative 2x. And then flipping that around, we get dx equals du over negative 2x. Okay, so now we just plug the stuff in here, and we have the integral. We're going to take care of the limits of integration in just a minute. Actually, I want to explain that separately. So we're going to have here x, and then 1 minus x squared is just u, and square root means 1/2, so u to the 1/2. And dx is going to be du over negative 2x. And then we're going to get rid of those x's and kick the negative 1/2 onto the outside. And so that's going to be equal to negative 1/2 integral of u to the positive 1/2 du. Okay, so you'll notice that I've left my limits of integration off when I started with them as 0 and 1. But the limits of integration here, 0 and 1, are corresponding to x's, right? This is dx, and so these guys here are x's. But if we have changed this into u's, then these guys here have to be u's, not to be confused with u's guys. So we need to figure out what's the lower limit of integration and what's the upper limit of integration if we're going to be working with u. Well, that's easy enough. We know that u is the same as 1 minus x squared. Cool. So we'll just plug in 0 into here. So 0 squared is 0, 1 minus 0 is 1. So we're going to put a 1 down here because that's the same as 0 as we translate it from x to u. And then we do the same trick over here, put the 1 in here. 1 squared is 1, 1 minus 1 is 0, so we have an upper limit of 0. So now we're just going to plug the stuff in as is. Or actually, we're going to integrate first. So we integrate, and we get negative 1/2, we can't forget that. And we have u to the 3/2 divided by 3/2, aka times 2/3. And we're going to evaluate that on 1 to 0. All right, so that means, again, as usual, we're going to do negative 1/2. And we're going to plug in 0 this time. So 0, blah, 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 is going to be 0. Subtract, plugging in 1. 1 to the 3/2 is 1, times 2/3, well, is just 2/3. So we have 0 minus 2/3 is negative 2/3, times negative 1/2 is positive 1/3. And make sure I got that. Yeah, positive 1/3. Okay. And if you wanted to be cool, you could check this with your graphing calculator or some other sort of device. And, just doing this stuff here, 0 to 1, do the graph, etc., you should get 1/3. All right. So, again, the key little trickiness here was making sure that you change your limits of integration to match up with your u's. All right, so let's flip and do the same. Just got 4 more problems to go. Sorry, this video is getting longer than I wanted it to be. All right, so maybe we'll just start this. We won't actually go all the way with this one. All right, so let's do, again, we have an inner function. And we look here, x cubed minus 1. What's the derivative of x cubed? 3x squared. That's an x squared. All right. So u looks like a good choice. Or I'm sorry, x cubed minus 1 looks like a good choice for u. X cubed minus 1. And then we do our du dx trick here. So du dx equals 3x squared. And dx equals du over 3x squared. And we're just going to sub in now. So we got x squared, and then we got u cubed, and we got du over 3x squared. And now I don't need to re-explain the whole limits of integration trick, so we're just going to plug in -1 here. So -1 cubed is -1, subtract 1 more is -2. And I'm going to plug in 2 here. 2 cubed is 8, minus 1 is 7. And then we're going to drop off the x squareds and kick the 1/3 onto the outside. So now I got 1/3 integral from -2 to 7 of u cubed du. So that's going to be 1/3. I didn't quite need to do that yet. Of u to the 4th over 4, evaluated on, where am I here? -2, 7. And so we're just going to plug in -2 here and 7. So we got 1/3, square bracket, plug in the 7 first. So 7 to the 4th power, who the hell knows what that is? So 7 to the 4th power over 4, and we're going to subtract -2 to the 4th power, which is 16. 16 over 4, which of course is just 4. So whatever 7 to the 4th is, divide, and then we just do our whole, well, we got common denominators, but 7 to the 4th minus 16, all of that over 4, multiply that by 1/3, and that is your final answer. So whatever that comes out to be, not gonna chew up time to do that. Okay, same type of situation right here. So we got 4 minus x squared, kind of similar to what's going on right here. And we have a derivative right here, or at least something that looks like the derivative of 4 minus x squared. It's an x. This would be a 2x. So let's save some time. We're already at 23 minutes, so let's just say you can do this, right? U is this. So just start it. U equals 4 minus x squared. And then you do, du dx, blah, blah, blah. Do all the substitutions, cross off the x's, kick out the 3, and change the limits of integration, and you're good to go. All right, so saving some time here. Let's do our last 2 problems. The last, of course, will be a trig problem. So the second to last one here is like the second to last one on the when we were not doing u substitution. I saved kind of the hardest for second to last before the trig problem. Excuse me. Okay. Here we have the integral from 1 to 8 of 2 over the cube root of x times 2 plus the cube root of x squared. Now at first this doesn't really look like it's the derivative of this, but thinking about this, and I think I'm going to need this. That's a squared there. So I'm pretty sure that's going to be good now that I think about it. Okay, so let's do our, looks like this is our inner function right here, and we'll hope that 2 over the cube root of x squared is going to be more or less what our derivative is. And if I did things in my head correctly, then we should be okay. All right, so u is going to be 2 plus x to the 1/3. and du dx equals derivative of 2, of course, is 0. So then we're going to have yeah, we're going to be okay. Yeah, we're going to be fine. Yes, we're good. Okay, so we're going to subtract 1 from 1/3, and we're going to get negative 2/3. So we have x to the negative 2/3. And then we flip this around, and we get dx equals du over x to the negative 2/3. But of course, because it's a negative exponent, I'm going to bring it right up here and make this times x to the 2/3 right there. Okay, so let's begin to do some rewriting here. So we're going to do the integral. We'll check the, well, actually we'll do it right now. So we'll plug in 1 right here. Cube root of 1 is 1, plus 2, she is 3. Plugging in 8, cube root of 8 is 2, plus 2 is 4. Well, it's kind of convenient. Tightened all that down. And, okay, so then we're going to do 2 over, and this is going to be x to the 2/3, right? Cube root, the root's on the bottom, the power's on the top, so this is x to the 2/3. Good. And then we got u squared. And we have du times x to the 2/3. And so we're going to take the x to 2/3 and cancel it off with the x to the 2/3. So that's outie. And then we're going to bring this thing up here. So this is going to be equal to the integral 3 to 4. Well, actually, I'm going to kick the 2 on the outside, put the 2 out there so we don't need it on the inside. And we got u to the negative 2 du. Okay, and then we integrate u to the negative 2 by doing the usual adding 1 trick. So now we have 2 times u to the negative 1 over negative 1. So we'll just stick a negative here in front. And we'll evaluate that on 3 to 4. So we have 2. And we have negative 1 over 1 over u. Just kind of cleaning this up here a little bit so we can work with it better. And then we're just going to now plug in the stuff. So we got 2 times, put a 4 in here, so negative 1/4, minus, put a 3 in here, negative 1/3, oops, negative 1/3, yep. And subtracting negatives like adding a positive. So here we have 3/12 here, so negative 3/12, and we got 4/12, so it's going to be 1/12 times 2 is 1/6. Hopefully I did my calculations right. Right, 3/12, 4/12, negative, positive, 1/12 times 2. Yeah, 1/6. Okay, cool. Last problem. Wow, it's get to be half an hour already. Time flies when you're having fun. Okay, so seal that off right there. So we have an inner function which is 2x. So we got u equals 2x, du dx equals 2, and dx equals du over 2. So we have integral. And again, as usual, we're going to plug this right in here. So 0, 2 times 0 is 0. Plug in pi over 4. 2 times pi over 4 is pi over 2. And here we have the sine of u. And du over 2. Kick the 1/2 on the outside. So we got 1/2. 0 to pi over 2. Sine of u. Du. Okay, then we ask ourselves, what is this the derivative of? And this is the derivative of negative cosine. So this is 1/2 negative cosine of u on 0 to pi over 2. So we get 1/2. and then we plug in pi over 2. So we have negative. The cosine of pi over 2 is 0. So we have negative 0. Minus plugging in 0 into this. So this is going to be cosine of 0 is 1, but it's actually really negative 1, so minus a negative 1. So this is going to be 0 plus 1, which of course is 1, times a half is a half. And there you go. There's the lesson. I will post on Classroom the assignment and a picture of the page so that you can be able to do the problems that I want you to do for this particular lesson. So there you go. Sorry it was a little longer than I wanted it to be. It's almost 31 minutes. So enjoy the lesson, enjoy the homework assignment, and I'll see you on Friday. Thanks.